Welcome to this model. In this model, we are going to see about the protocol layering. In computer networks, communication occurs between entities in different systems. An entity is anything capable of sending or receiving information. However, two entities cannot simply send bit streams to each other, expect to be understood. So, for communications to occur, the entities must agree on a protocol. A protocol is a set of rules that govern data communications. A protocol defines what is communicated, how it is communicated, and when it is communicated. The key elements of a protocol are syntax, semantics, and timing. The term syntax refers to the structure or format of the data, meaning the order in which they are presented. For example, a simple protocol might expect the first 8-bit of data to be the address of the sender, the second 8-bits to be the address of the receiver, and the rest of the stream to be the message itself, right? The word semantics refers to the meaning of each section of the bits. How is a particular pattern to be interpreted and what action is to be taken based on data interpretation. For example, does an address identify the route to be taken or final destination of the message? And the term timing refers to two characteristics: when data should be sent and how fast they can be sent. For example, if a sender produces data at 100 Mbps, but the receiver can process data only at 1 Mbps, the transmission will overload the receiver and some data will be lost. Next, let us move on to standards. Standards are essential in creating and maintaining an open and competitive market for equipment manufacturers and guaranteeing the national and international interoperability of data and telecommunication technology and process. Standards provide guidelines to manufacturers. So the standards can also provide guidelines to vendors, government agencies and other service providers to ensure the kind of interconnectivity necessary in today's marketplace and in international communication. Data communication standards fall into two categories: de facto, meaning by fact or by convention, and de jure, by means of by law. So de facto is a standard that haven't been proved by an organized body but have been adopted as standards through widespread use, or de facto standards. De facto standards are often established originally by manufacturers who seek to define the functionality of a new product or technology. De jure, those standards that have been legislated by an officially recognized body, are de jure standards. In data communication and networking, a protocol defines the rules that both sender and receiver and all intermediate devices need to follow to be able to communicate effectively. When communication is simple, we may need only one simple protocol. When the communication is complex, we may need to divide the task between different layers, in which case we need a protocol at each layer, that is called protocol layering. Now, let us develop two simple scenarios to better understand the need for protocol layering. The first scenario, communication is so simple that it can occur in only one layer. Assume Maria and Anne are neighbors with a lot of common ideas. And communication between Maria and Anne takes place in one layer, that is face to face, in the same language, as you can see in the diagram. This is a simple scenario, right? Even in this simple scenario, we can see that a set of rules needs to be followed. First, Maria and Anne know that they should get each other when they meet. And second, they know that they should confine their vocabulary to the level of their friendship. Third, each party knows that she should refrain from speaking when the other party is speaking. And fourth, each party knows that the conversation should be a dialogue, not a monologue. Both should have the opportunity to talk about the issue. Fifth, they should exchange some nice words when they leave. We can see the protocol used by Maria and Anne is different from the communication between a professor and a student in a lecture hall. So in this case, the communication is mostly monologue because the professor talks most of the time unless a student has a question, a situation in which the protocol dictates and that she should raise her hand and wait for permission to speak. So in this case, the communication is normally very formal and limited to the subject being taught. In the second scenario, we assume that Anne is offered a high-level position in her company but needs to move to another branch located in a city very far from Maria. The two friends still want to continue their communication and exchange ideas because they have come up with an innovative project to start a new business when they both retire. They decide to continue their conversation using regular mail through the post office. However, they do not want their ideas to be revealed by other people if the letters are intercepted. So they agree on an encryption and decryption technique so that no one knows about those messages. The sender of the letter encrypts it to make it unreadable by an intruder. The receiver of the letter decrypts it to get the original letter. We assume that Maria and Anne use one technique that makes it hard to decrypt the letter if one doesn't have the key for doing so. Now, we can say that the communication between Maria and Anne takes place in three layers. We assume that the Anne and Maria each have three machines that can perform the task at each layer. So this diagram shows that second scenario. Now let us assume that the Maria sends the first letter to Anne and Maria talks to the machine at the third layer as though the machine is Anne and is listening to her. The third layer machine listens to what Maria says and creates a plain text, that is a letter in English, which is passed to the second layer machine. The second layer machine takes the plain text, encrypts it and creates the cipher text, which is passed to this first layer machine. The first layer machine, preferably a robot, takes the cipher text and puts it into an envelope and adds the sender and receiver address and mails it. So at Anne's side, the first layer machine picks up the letter from Anne's mailbox, recognizing the letter from Maria by the sender address. The machine takes out the ciphertext from the envelope and delivers it to the second layer machine. The second layer machine decrypts the message and creates the plain text and passes the plain text to the third layer machine. The third layer machine takes the plain text and reads it as though Maria is speaking. That's how they both communicate with each other without any disturbance. So protocol layering enables us to divide the complex task into several smaller and simple tasks. For example, we could have used only one machine to do the job of all three machines. However, if Maria and Anne decide that encryption and decryption done by the machine is not enough to protect their secrecy, they would have to change the whole machine. So in the present situation, they need to change only the second layer machine. The other two can remain the same. This is referred to as modularity. So modularity in this case means independent layers. Each layer is independent of others. A layer can be defined as a black box with the inputs and outputs without concern about how inputs are changed to outputs. If two machines provide the same outputs, when given to the same inputs, they can replace each other. For example, Anne and Maria can buy the second layer machine from the two different manufacturers as long as the two machines create the same ciphertext from the same plain text and vice versa. They do the job. One of the advantages of protocol layering is that it allows us to separate the services from the implementation. A layer needs to be able to receive a set of services from the lower layer and to give the services to the upper layer. We don't care about the layer, how the layer is implemented. For example, Maria may decide not to buy the machine for the first layer. She can do the job herself. As long as Maria can do the task provided by the first layer in both directions, the communication system works. Another advantage of protocol layering, which cannot be seen in a simple example but reveals itself when we discuss the protocol layering in the internet, is that the communication doesn't always use only two end systems. There are intermediate systems that need only some layers but not all layers. If we didn't use protocol layering, we would have to make each intermediate system as complex as the end systems, which makes the whole system more expensive. So this is one more advantage of layering the protocol. And now let's see the disadvantages of protocol layering. We can argue that having a single layer makes the job easier. There is no need for each layer to provide a service to the upper layer and give service to the lower layer. For example, Anne and Maria could find or build one machine that could do all three tasks. However, as mentioned above, if one day they found that their code was broken and each would have to replace the whole machine with a new instead of just changing the machine in the second layer. And now let's see the principles of protocol layering. The first principle dictates that if we want a bidirectional communication, then we need to make each layer so that it is able to perform two opposite tasks in one direction. And for example, the third layer task is to listen and talk, and the second layer needs to be able to encrypt and decrypt. The first layer needs to send and receive mails. And the second principle is that we need to follow in protocol layering is that the two objects under each layer at both sides should be identical. For example, the object under layer 3 at both sides should be a plain text letter. The object under layer 2 at both sides should be a ciphertext letter. The object under layer 1 at both sides should be a piece of mail. And after following the above two principles, we can think about the logical connection between each layer. This means that we have layer-to-layer communication. Maria and Anne can think that there is a logical or imaginary connection at each layer through which they can send the object created by that layer. So this is how protocol layering works. Thank you.